Welcome back. In this video, I'll be solving Leetcode problem 207 course schedule. There are a total of 9 courses. You must be, for example, so course false. Okay, number of courses 2. AI. Okay. Hmm. Okay, let's try to get this one. Because you have to take core 0. Okay. So required and core in prerequisites adjacency of so required for course is equal dot append required. Okay. If rack not in core, well, actually I need it other way around. Is it like this? So required, if required not in like this age of, but that's already true. So okay, so if length of AJ is equal to non-courses, then return false, because everyone has a requirement. But if not, so for starter in, for course start in range non-courses. If start not in starters, so Q is equal to deck for start in range. If start not in adjustment adjacency, DQ. Well, I could have done it much easier. I for I in range non-courses. If I not in H, something like this. Visited is equal to set, I guess. Okay. Now Q. Course. So Q is pop left. So I take a course. I'll call it finished. Course is pop left. If course I think I should have done it the other way around. So yeah, I should have done it the other way around. So, but that's kind of not true because I need all the prerequisites. So if course not in finished course, of course not in finished, finish. Okay, and now I need to check if there is something new I can potentially add. Well, instead of going all the way, reverse will be also default text set, but for core opens, let's call it that, opens off required dot required adds course. And now so continue finish, and now I need to check for potential in opens of course if and this should be rec. Let's keep it this way. So if for potential in open course, so potential, if should be something like this. So if let's do it stupid way. So flag is true. So for age of potential, so for C in age of potential, if C in finished, continue as flag is equal false, if flag q dot append potential. Something like this. No courses. Default. Okay, looks good and nice. Got it first try. Doesn't happen often, sadly. But yeah. Well, let's see, time complexity, space complexity. So what are we doing here? Space complexity, we have, so for each course, we build adjacency list, and if for each course every other course is required, then I would have to go. Well, time complexity would be O of non-courses squared, because for each one I would have to, well, would I? Well, if it was just accept one. But then I wouldn't be able to do it, so let me think about it. Yeah, then only one is required. Well, I think worst case is it's again n plus m or whatever. So number of vertices, number of edges. Space complexity, I think, again. Well, actually, here is v times z. Oof, sorry. To do this. Maybe it's v times z even here. Oh, shame. V plus z. Well, I think it's v times z. Because for each v, I will have e. Yeah, but those are not all, so yeah, v plus c. I think it's both v plus c. Kind of messed it up here. Yeah. If everything is connected to everything, so if I have three, let's say, elements, I have three, it's directed, so I can have for each one I have two actually. Yeah, I'm not sure. I need to get better with graphs and complexities, but should be this. Maybe, yeah, b plus c. Kind of not sure how to confirm it, but yeah, so for each we have each pair, and for each one we build it's v squared, because each one can have at most, I have v vertices, and each of them can be connected with v minus 1 other vertices, so that's why it's and is total number of edges, so yeah, b squared. Okay, I'll wrap it up. If you have any questions, leave them in comments, and yeah, I appreciate you for following this one, and see you in the next one.